Welcome, everyone! Today, we're diving straight into a truly cinematic explainer based on the incredible TerraVerse TV documentary. We're exploring the awe-inspiring and honestly kind of terrifying power of Earth's volcanoes. We're going to look past all those Hollywood myths and uncover the real, hidden wonders of our incredibly active planet. Let's get right into it.
So I gotta ask you, are you ready for a vacation? Picture a place with absolutely stunning views, steaming hot springs, and breathtaking waterfalls. I'm talking about Lake Taupo over on the North Island of New Zealand. It looks like absolute paradise, and well, it's pretty obvious why it's such a massive tourist destination. It just seems perfectly peaceful, right?
Well, not exactly. This gorgeous destination actually has a violently explosive origin story. Seriously, about 25,000 years ago, you absolutely would not have wanted to be anywhere near this place. This peaceful lake was actually born from a massive volcanic super eruption. It hurled out just an enormous amount of lava and ash, and it caused the ground to completely collapse into a massive depression, literally the size of Singapore. Over time, that giant crater filled with water and became the beautiful, yet somewhat terrifying, Lake Taupo.
Okay, let's dive into this. To really understand how a beautiful lake can be born from such catastrophic destruction, we kind of have to travel beneath the surface. You know, fictional volcanoes like Mount Doom get all the fame, but real volcanoes? They are way stranger and way more powerful. We need to look at the hidden world of magma.
First up, let's talk about what a volcano actually is. Geologically speaking, a volcano is basically a crack or a vent in the ground where lava escapes to the surface. We usually use the word to describe the mountain shape that builds up around that vent, but we really shouldn't just think of them as these static, unchanging mountains. They are highly active, living systems.
Let's travel a bit deeper to see what's actually happening underground. So, molten rock beneath the surface is called magma. Down there, temperatures can reach a staggering 1,000 degrees Celsius, and the pressure? It's just unimaginable compared to what we feel up here. This intense heat and pressure allow gases, like water vapor, carbon dioxide, and sulfur, to dissolve directly into the molten rock itself. And because this magma is less dense than the solid rock surrounding it, it slowly rises up and collects in these huge underground reservoirs we call magma chambers.
Think of that magma, which is absolutely packed with dissolved gas, kind of like a vigorously shaken bottle of soda. As long as the cap stays tightly sealed, all that pressure is contained, right? Nothing happens. But introduce even a tiny crack in the rock above, essentially loosening that cap just slightly, and the pressure suddenly finds a way out. All those dissolved gases have a clear path to the surface, and they rush upward, carrying all that molten rock right along with them. The second it breaks the surface, we call it lava, and boom, that is an eruption.
But as you probably know, not every eruption looks the same. Let's look at how the actual chemical makeup of that lava creates entirely different types of volcanoes.
The absolute game changer here is a compound called silica. Silica is one of the most common compounds on Earth, and it completely dictates how thick or runny the lava is going to be. First, we have mafic lava. This is your low silica lava. It's super runny, flows really quickly, and basically races across the land like a fiery river. Then on the flip side, we have felsic lava. This is high silica lava, which means it's incredibly thick and sticky. And because it's so thick, it actually traps all those dissolved gases inside, allowing immense pressure to build and build until it finally explodes violently.
And these different types of lava physically sculpt the Earth in completely different ways over time. The runny lavas form shield volcanoes, think Kilauea in Hawaii, which are broad, low, and gently sloped, almost like a warrior's shield resting on the ground. Then you have cinder cones, like Paracatin in Mexico. These are small, steep volcanoes built mostly from fragments of rock and ash called tephra. Next up are the towering composite volcanoes, or stratovolcanoes, like Japan's Mount Fuji. Those are built from layer upon layer of highly varied eruptions. And finally, when lava is just extremely thick and sticky, it simply piles up right at the opening, forming a really steep lava dome.
But what happens when an eruption is so incredibly massive that it literally empties out the entire underground chamber? Well, that creates a caldera. A caldera is a massive, bowl-shaped depression that forms when the ground completely collapses inward after an enormous eruption rapidly drains the magma chamber below. Remember our little slice of paradise at the beginning of the explainer? Yep, this is exactly how Lake Taupo was formed.
So we know what they are and we know how they get their shapes, but where do they actually come from? I mean, volcanoes are scattered all over the planet, but they definitely don't just pop up at random. For magma to reach the surface, the global tectonic conditions have to be absolutely perfect. Volcanoes primarily form in three main types of locations.
First, you've got subduction zones, like the infamous Ring of Fire, where Earth's massive tectonic plates literally collide, forcing one plate down into the mantle where it melts and rises back up. This process creates those really explosive composite volcanoes. Second, we have divergent boundaries, where plates are pulling apart. Amazingly, over 70% of the world's volcanoes are actually hidden underwater at these mid-ocean ridges. In fact, geologists just recently managed to witness a mid-ocean ridge eruption for the very first time in 2025. Pretty wild, right? And finally, we have hotspots, where a plume of extremely hot mantle rock rises right up beneath the crust, driving massive systems like Yellowstone.
And hey, speaking of Yellowstone, let's address the massive, rumbling elephant in the room. It's time to look at the real truth about supervolcanoes.
So the term supervolcano definitely sounds like something straight out of a Hollywood disaster movie, right? Honestly, most geologists try to avoid using it. A supervolcano is simply a volcano that has produced at least one super eruption in its entire history. That's really it. It's all about the historical scale of an eruption, not a specific, terrifying type of mountain.
So just how big is a super eruption? Well, scientists use something called the Volcanic Explosivity Index, or VEI, which goes from 0 to 8. Just to put this into perspective for you, the absolutely strongest eruptions of the entire past century only reached about a 6 on this scale. A true super eruption, it hits the absolute maximum on the scale, an 8.
An 8 on the index means the volcano releases at least 1,000 cubic kilometers of ash, pumice, and debris. That is literally enough material to fill 400 million Olympic-sized swimming pools. Just let that sink in for a second. That is the staggering volume of material required for an event to be officially classed as a super eruption.
Now, what's really interesting here, and let's go ahead and debunk a major internet myth while we're at it, is that people constantly worry the Yellowstone hotspot is just this one massive, connected reservoir waiting to explode and end global agriculture forever. But volcanologists are constantly monitoring it, and recent studies show that while, yes, there is a lot of magma down there, it's actually spread across many small, disconnected pockets. It is absolutely not one giant, connected pool capable of erupting all at once. In fact, the last super eruption there was 640,000 years ago, and geologists say the odds of another one happening anytime soon are extremely, extremely low.
So while we really don't need to lose sleep over Yellowstone, ordinary volcanic eruptions remain a very real part of human existence. Think about this. Roughly 800 million people live within 100 kilometers of an active volcano today. So what is it actually like living with a restless planet? It's a relationship entirely defined by a dual nature. On one hand, you have very real, deadly threats. You've got thick ash that can collapse buildings, highly destructive mudslides called lahars, and incredibly fast-moving avalanches of superheated gas known as pyroclastic flows. But on the exact same token, volcanoes provide vital, life-giving benefits. The ash completely enriches the soil, making it absolutely incredible for agriculture. These regions are totally rich in valuable minerals like gold, copper, and zinc, and they provide abundant geothermal energy. Civilization practically thrives near volcanoes. Naturally, because we want all those benefits without the destruction, humanity has definitely tried to control them. Get this, in 1935, the United States Army actually attempted to redirect lava flows from Mauna Loa in Hawaii by dropping bombs on them from aircraft. I mean, as you might guess, it failed completely. The immense power of Earth's geology simply cannot be steered by human weapons. There is just no giant cork we can use to seal a volcano shut.
So the crucial point here is that instead of trying to stop eruptions, science focuses on forecasting them by monitoring if a system is active, dormant, or completely extinct. Geologists basically act like detectives, monitoring some incredible warning signs. They track frequent, localized earthquakes, they measure physical ground swelling as the magma literally pushes the Earth up. They watch for unexpected steam rising from vents, and they study recurrence intervals, which is basically the average time between past eruptions, to help predict when the next one might actually occur. And because science gives us these warnings, we can actually prepare. If you live near an active or honestly even a dormant volcano, preparedness is remarkably straightforward. Step 1, learn your local volcanic risks. Step 2, sign up for those local emergency alerts. Step 3, have a clear, well-thought-out evacuation plan. And step 4, keep basic emergency supplies ready to go. Things like food, water, masks, and protective clothing. We can't stop the eruption, for sure, but we can safely get out of its way.
Whether they're carving out massive calderas that eventually become beautiful vacation lakes, or simply releasing a little bit of steam, volcanoes are a constant, humbling reminder that the earth beneath our feet is very, very much alive. We've seen their terrifying power and their incredible geological beauty today. So I'll leave you with this question to ponder. The next time you see a mountain or gaze out at a perfectly still lake, how will you view it? Thanks so much for watching this explainer.